Hello, ProjectCS girls. I'm Nidhi.
And I'm Elizabeth. We're 7th graders from Saratoga, California.
And we're super excited to be sharing our project with you today. Our project is Start2Run. Start2Run is a device that measures the amount of stretch on a person's leg and will tell the runner when to stop if they're stretching too much.
So how did we come up with this idea?
So we came up with this problem when my dad started running last summer. One day he suddenly stopped, and when I asked him why, he said he pushed himself too far, and he had to stop before causing any permanent damage in his muscles. We decided to research a little bit more about this problem, and we came up with the following.
We discovered that every day millions of people run for all sorts of reasons. In fact, in 2016, over 64 million Americans went for a run. Running is a good exercise, but it can lead to complications or even permanent damage in a runner's leg. So let's move on to our solution, Start2Run. Start2Run has two main parts. The first part is the Arduino, which the stretch sensor is connected to and has all of our Bluetooth chips and LEDs. And the second part is the app, which we programmed using MIT App Inventor. It connects to the device using Bluetooth. So Start2Run is a prototype meant to make the runner more aware of the stretch produced by running on his or her legs. To start our research, we started by talking to Divya Tonkasala, a PhD student at Purdue who's studying biomedical engineering. She did a project for basketball players, so she was able to give us some input on the materials we should use. She suggested a Arduino Uno, a strain gauge, and a Wheatstone bridge. But after researching numerous articles on the internet, we decided to go with a stretch sensor instead of a strain gauge and voltage divider instead of a Wheatstone bridge. In the end, the materials we used were an Arduino Uno, a voltage divider, a stretch sensor, and a Bluetooth chip. By using encoding in Arduino Uno, our project falls under intelligent technology. Intelligent technology is important for the world because it makes our job as humans easier, so we will have more time to focus on less recognized areas.
So now let's move on to the parts of Start2Run. As Elizabeth mentioned before, we have the Arduino Uno, the stretch sensor, the voltage divider, and the Bluetooth chip. The stretch sensor works as follows. It changes its resistance based on how much it is bent. The voltage divider is a circuit which turns a large voltage into a smaller one using just two series resistors and an input voltage. Through a voltage divider, we can convert a change in resistance, which the stretch sensor gives us, to a change in voltage, which the Arduino can read. The Arduino is a microcontroller, or as we like to call it, the brain of the system. Finally, we come to the Bluetooth chip, which provides the Bluetooth we need in order to connect the device with the phone.
To start off, we first connected the voltage divider and the stretch sensor using the breadboard. Next, we connected 3 wires going out from the voltage divider into 3 different analog inputs. To finish off the basics of the hardware part, we connected the Arduino to the LEDs via the breadboard to show the stretch. The more stretch, the brighter the LED. But in the end, we decided to make the white LED flash to indicate that our device is on, and also have the green LED turn on and off, controlled by a button on the phone, which is connected by Bluetooth.
Next, we try to write a program that will 1. Measure the amount of stretch produced by the stretch sensor, 2. Scale the number using a scale factor, and then compare it to the maximum amount of stretch there can be, and 3. Connect the Bluetooth device with a phone, and using MIT App Inventor, create a graph and alert the runner if they've crossed the stretch limit. To start off, we measured the amount of stretch produced by the stretch sensor. We then send this value to the voltage divider. Now, we're on step number 2, scaling the number using a scale factor and then comparing it with the maximum amount of stretch there can be. The scale factor we used was 255 divided by 300. We got this value through testing out the stretch sensor when we first were starting. If you would like more information about how we arrived at the scale factor, please refer to our write-up. After finding the stretch value and scaling it, we compare it with the maximum amount of stretch there can be, which is 192 ohms.
We plan to talk to a physical therapist more about this value soon. After we compare this value to the maximum, we sleep for 10 seconds before running the program again. Finally, we connect the phone to the device using Bluetooth, and using the app we created on MIT App Inventor, we plot the graph. Here is the main program and our demo.
So as you can see, this is our main program. This is where we start or initialize. And then this entire part is where we're finding the scale factor. Over here, we're mapping it to the LEDs and printing the result on the serial monitor. And finally, over here, it's where we are comparing it to what we are saying is the maximum amount of stretch, 192 ohms. And finally, we are delaying it by 10 seconds.
Okay, so that was the program for the Arduino. Now let's move on to the program on MIT App Inventor that we use for our app. So the first part is enabling the location sensor, which we use for GPS to find the person's location. This is basically putting it into our app. This is using Bluetooth to turn on and off the green LED. This is making sure Bluetooth is connected and initializing it. This is connecting and disconnecting Bluetooth. Over here is basically making the canvas for our graph. It basically makes it look better on the phone. Over here is the actual graphing, how it graphs. And if the stretch value is too much, the message, your leg is under a lot of strain, try to catch your breath, is said.
So now let's move on to a demo of how our prototype actually works. So when you want to connect it, we press the connect button and we get to this black screen and we press this device, which is actually the Bluetooth chip over here. After a few seconds, we get back to the original screen we were at. And we can see that if we press it too far,
your leg is under a lot of strain. Try to catch your breath for a few minutes.
We get the alert message that Elizabeth had mentioned previously. And as you can see, we have the LEDs on and off again. And we actually have a latitude and longitude, which we are currently working on. We're gonna clean it up a little bit, so soon we can have it such that the runner has a route that they can go on, and so the phone will be telling them where to turn at which point. And so that's our latitude and longitude, and it basically shows where you are on the Earth.
So Start2Run is a great solution for all runners experiencing pain, but it doesn't stop there. We can implement this into a whole other worldwide problem, earthquake damage. Earthquake damage under houses is one of the main causes of home damage in earthquake zones. Water pipes or even gas pipes can break after an earthquake. Once the homeowner decides to turn on the water or even use their gas, the pipes can cause a major problem, including flooding, and could even bring down an entire house. So here is a diagram of how we could use our product. So basically, this is the floorboards of a house. Under it, there's pipes connected to the supports using C-clamps, and the pipes can run perpendicular to each other. And this is like the underview of the house. Looking up to the house, there is 2 pipes running perpendicular, and we can put a stretch sensor in between that. So after the earthquake, if the pipes move, the stretch will change, and the homeowner will get an alert on their phone using Bluetooth. So they don't even need to use Wi-Fi.
In conclusion, our product can be used for runners and for houses in earthquake zones all around the world. Our product can determine whether or not a runner is stretching themselves too much and can tell them to stop and alert them using the app we created on MIT App Inventor. Start2Run can also connect to a runner's phone using Bluetooth. During this process, we learned so much, including the basics of electrical engineering, such as Ohm's law and the voltage divider, what is and how to determine a scale factor, what an Arduino is and how to program it, and last but definitely not least, how to connect a Bluetooth device to an Arduino.
So right now, we're actually in the middle of implementing GPS. Our program can tell us where you are on the Earth using latitude and longitude, but we plan to further clean this up so that the runner can tell where they are and how long they can run without developing injuries or muscle strain. Soon, we also plan to measure the specific person's average, their high and low, instead of basing it off a few data samples. We also plan to extend Start2Run's uses into other sports and into houses in earthquake zones, which we explained before. Overall, Start2Run is an effective way to ensure that runners do not injure themselves through muscle injuries. Hello, ProjectCS girls. We are here at Nithy's house, the testing ground. We're going to be testing on her dad, real life subject, Start2Run.
Yeah, so in a few minutes, we'll see it, our prototype in action.
Yeah, he'll be out here running with it. Let's go.
Before running, place Start2Run between the ACE bandage and the person's knee, as shown in the picture. This image shows the graph before the person starts to run. Now, let's move on to the actual video of the live subject running. Come on, you're doing good. You're doing good. Come on, stretch some more. Here's a picture of the graph after the live subject is done running. As you can see, our prototype has worked because the graph definitely has some changes in stretch.